Hello. I guess I am audible. So, good evening, everyone. Hope everyone is doing fine and had a great morning, evening, good night, wherever you're situated. So, today's agenda is solving leetcode Amazon interview questions. It is gonna be so fun. So, I think we ended yesterday's stream by solving 5 Amazon interview questions. Now we need to solve. We have solved 30 out of 45 Amazon interview questions from recent 6 months, past 6 months, and now we're gonna solve the rest 15, at least 5 or 4 today, and then we will also solve the POTD. So let's dive into it. And remember, even I am seeing these problems for the first time. So it's not that I'm coming prepared and solving them in an instant. I would solve these problems with you. I would give you 5 to 10 minutes to solve the problems along with myself, and then we would have the solving session. You can ask any questions if you want right now. I would be happy to answer. I'll wait for 2 minutes while putting a rain sound on, and then we would start solving the lead code question. So this is my rain sound. I will click on a media player, and here it is. So no questions it seems. Okay, Simran has a question. Yes, Simran, I'm hearing. Simran, are you there? You can type your question in the chat itself. Okay, I guess nobody has any questions. I will just start the live stream. So these are the questions. Okay, we have solved, I think, around 29 questions. 30 questions. So now solve. Let's solve the string to integer question. Okay, let's minimize the solution stack. We don't need. Let's read out the topic. String to integer. So implement the my A2OI string is function which converts a string to a 32-bit signed integer. The algorithm for my A2OI string is as follows. White space. Ignore any leading white space. Signedness. Determine the sign by checking if the next character is minus or plus, assuming positivity if neither present. Conversion. Read the integer by skipping leading zeros until a non-digit character is encountered. Or the end of the string is reached. If no strings, if no digits were read, then the result is zero. Rounding. If the integer is out of the 32-bit signed integer range, then round the integer to remain in this range. Specifically, integers less than negative of 2 raised to power 31 should be rounded to minus negative 2 raised to power 31, and integers greater than 2 raised to power 31 minus 1 should be rounded to 2 raised to 31 minus 1. Return the integer as the final result. So input string s equals to 42, output would be 42. The underlined characters are what is read in, and the caret is the current keyword position. No character is read because there is no leading white space. No character is read because there is neither a minus or plus. 42 is read in, and if no signs are present, neither a minus or plus, it is assumed to be a positive integer. Leading white. Let's see the second example. Leading white space is read and ignored. Dash is read, so the result should be negative. And 042 is read in, leading zeros ignored in the result. So our answer is minus 42. Now let's see the third example. 1337 C0D3. So here no characters read because there is no leading white space. The second step is no characters read because there is neither a negative nor positive. The number 1337 is read in. Reading stops because the next character is a non-digit. So now we get our output as 1337. Even if you encounter a single non-digit character, we have to stop reading. And whatever we read up until that non-single digit character would be our answer. So let's see the fourth example. 0 dash 1. So let's see the step 1 is no character is read because there is no leading white space. No character is read because there is neither a negative or positive sign. 0 is read in. Reading stops because the next character is a non-digit. So now our answer would be a simple 0. The fifth example is S equals to words and 987. So let's build it. Reading stops at the first non-digit character W because we don't want characters, we want digits. Only the leading white space is allowed and a leading minus or plus sign. Nothing else is allowed at the starts with. If it's a character, we stop. Here it is a character W, so we stop immediately. So we can write the conditions. Leading, so white space is allowed. And after white space or normal, after white space or no white space, a negative or positive symbol is also allowed. Now, after this, we also have one more condition. At the first non-digit character, we stop and return every digit before as our answer. So these are the conditions, and our S length, the string length can range from 0 to 200. S consists of English characters, lowercase and uppercase, digits 0 to 9, white space, plus symbol, minus symbol, and period. So this is the question. Let's think about the question now for 3 to 5 minutes. Then we would discuss the solution together. You can ask anything in the live chat if you didn't understand about the question. I would be happy to answer. Okay, I would see if somebody has asked any question. So, Rishi is asking, can you use CPT? See, problem solving is language agnostic. So it doesn't matter if I solve in C++ or Python or Java. You just need to understand the logic. You can also practice like this to convert the Python code into your own language so that you don't copy paste the whole code. So your language skills would also get improved. You would know how to convert one language code into other. This is done a lot in your companies. Like they have to change some legacy code. So you should know how to get the underlying logic from the code and convert it into your own programming language. So it doesn't matter if I use CPP, Java, or Python. The logic remains same. You can just see the docs. We have CPP docs, right? CPP algo docs, and also CPP official site where you can get the syntax help if you forget something in case. Same goes for Java. We have Java's official docs and Python's also. So in here I'm gonna solve in Python, but in case you're having problems in converting that code to CPP, just paste your solution here. I would help you out. So let's go to the question now. Again, I'll wait for 3-4 minutes and then we would start writing the solution as well as I would explain you why I did what I did. Until then, don't go to the solution tab and watch solution. Instead, try to dry run. Read these four conditions properly again and see if you don't miss any of these conditions while developing your code logic. Okay, so this is a simple read the instructions and write the code type problem. We are initializing our pointer I equals to 0. N would be the length of our string s, while I is less than n, and s of I is equal to a white space. we would increment I by 1. Now sign is also a boolean variable. We are assigning its value to 1. That means the sign is positive because it is given in the question that if no sign is mentioned, we are assuming it to be positive here, assuming positivity if neither is present. So now if I is less than n and s of I equals to the dash or minus, or s of I is plus. So our sign would be equals to minus 1 if the sign of I is equals to minus, as it is a negative integer, else it would be 1. I would increment my I pointer by 1 now. Initializing the result with 0. I'm again gonna iterate using the while loop, and s of I dot is digit is for check if the I position is a digit or not. If it is a digit, it will return true, and if it is not a digit, it will return false. And we are using while I less than n, and the true or false condition from this s of I is digit. So if both the conditions are true, then only we are gonna go inside the while loop. So now we would populate our result with result equals to result into 10 plus integer value of s of I. So basically we are adding digits at the unit place by multiplying the result by 10. So if result into 10 into sign, into sign is greater than 2 raised to 31 minus 1, we would return 2 raised to 31 minus 1 as mentioned in the question's uh, instructions, minus 1. And if my result is result into sign, okay, sign is less than negative of 2 raised to 31, it is mentioned here rounding statement. So we are just converting this statement into code. We would return negative 2 raised to 31. That is it. And at last we would increment our pointer because we are moving ahead in the string given to us. And at last we would return result into whatever sign we finalized during this process. So this is our answer. This problem was a basic math problem, so I think this was an easy problem. But still, you learn how to convert the language of the problem into code, so it is a very good problem in a beginner sense. So we solved this problem now. Let's find out another problem to solve. Game of life. Let's go with this. If you had any questions uh, for the previous string to integer problem, you can ask me. Okay, I think no questions for now. So let's start with this game of life problem now. According to the Wikipedia article, the game of life, also known simply as life, is a cellular automation device by the British mathematician John Horton Conway in 1970. The board is made up of an M cross N grid of cells where each cell has an initial state, life, represented by a 1, or death, represented by a 0. Each cell interacts with its 8 neighbors, horizontal, vertical, diagonal, using the following 4 rules, taken from the above Wikipedia article. Any live cell with fewer than 2 neighbors dies as if caused by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies as if by overpopulation. Any live cell, any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. The next state of the board is determined by applying the above rules simultaneously to every cell in the current state of the M cross N grid board. In this process, births and deaths occur simultaneously. Given the current state of the board, update the board to reflect its next state. Note that you do not need to return anything. So we have to modify the board and return that board itself. So let's see the first example and what it says. So this is our board. We'll check each cell. This 0 has only a single live cell around it, so it would die. So it remains 0 in the board. And this live cell 1 has 0, 0, 0, 0, only one live neighbor. And here it is given in the first statement that any live cell with fewer than two live neighbors dies. So this one would be changed to 0 because it died. As for this cell, now it has 0, 0 and 1 as its neighbors. Again, the dead cell does not have 3 live neighbors, so it doesn't get affected. It remains 0. Now for this one, it has neighbors as 0, 0, 1, 1. It has 2 live neighbors. This one is 0 again. So any live cell with 2 or 3 live neighbors lives on to the next generation. So any dead cell with exactly 3 live neighbors becomes a live cell. So this has 1, 2 and 3 live neighbors. So this becomes 1 here. All the changes would happen simultaneously as it's written. So using the neighbors as this cell, we would transform them to some other. This 0 cell has 1, 2, 3, 4, 5 live neighbors. But it should have exactly 3 live neighbors to become a live cell. So nothing happens to this. Like this, the process goes on, and we find out that our the first word was transformed into this, and we will return this as our answer. So this live cell has 2 live neighbors, so it remains a live cell. This live cell has 2 live neighbors, so it remains a live cell. This live cell has again 2 live cells, so it remains live. This dead cell has 3 neighbors which are live, so it becomes live. So that is why we return this grid as our answer. These are the constraints. M and N values are ranging from 1 to 25. And board of ij can be either a 0 or a 1. So this is the question. You have to pay attention to only these 4 statements and how to convert these statements into code. So we understood the problem properly. If you have any questions, you can ask in the chat. Let's wait 5 minutes and try to solve this problem in our own language. And then I'll solve it for everyone and explain each and every step. So now the 5 minute time is over. Let's discuss the solution. And I would make you relate to these statements. So don't worry, you would understand it very well. So first we will create a deep copy or just copy each row. We want to copy the entire matrix in a temporary variable. Let's name it temp. Create temp board, deep copy of the board. That means uh, a board in another dimension space with exactly same values as the board given to us. And then create a moves list. It must contain all possible moves, that is in the 8 directions: horizontal, vertical, and diagonal as it's given here in the question. Now step 3, we have to go through each cell of the board and we have to maintain the counter for neighbors for each cell in the board that counts total numbers. Check the constraint if the neighbors are inside our board, and then just apply the rules, these 4 rules. Check for conditions and update the value. So let's write the code. Temp equals to the deep copy of board. Very important. C would be our column, which would be length of board 0, and R is our row, with length of board. Now we would keep a moves array, which helps us move in all the 8 directions. This we did yesterday also in the, I think it was a bomb problem. So Amazon loves to ask such questions where you need to traverse in some direction. So let's just write these 8 directions. 0, 1 is the up direction. 0 - 1 is the down direction. -1 is the left direction. Sorry, the diagonal direction. -1, comma 0. This is, and at last another diagonal direction. We have 1, 2, 3, 4, 5, 6, 7, 8 directions. So we got 8 direction moves. Now we would iterate over each cell inside our deep copy. That means an exact same copy of the board given to us, but in a different memory location inside our CPU computer. For J in range, this is just two for loops for iterating over a two-dimensional board. This remains same in any programming language. Now, as we discussed, we would keep count of our neighbors. Everything depends on our neighbors, on how we change the value. And which neighbors? Live neighbors. So we are counting live neighbors using this because they only matter and they our value changing depends on these neighbors. So let's for x y in our moves array we are iterating over each pair of directions possible above declare valid possible moves. Now we would check if in after going to these directions we are still inside our board or not. This condition is important to check. Otherwise, we would have our neighbors count as a discrepancy. And outside the board, we don't have a value for those columns. Like board of I and J would not point to anything if we go outside the board. So we need to check this condition that after going towards that direction, our new position remains inside our board. So we would do a simple check and 0 less than equals to j plus y less than c. Check boundaries. Now, if this new position, which is I plus x can be anything from these moves table, sorry, array, and j plus y, this is our new position. And if this new position has a value 1, we would increment our neighbors by 1, as this variable itself counts the neighbors with value 1. Now, if board of ij is equals to 1, we could have different set of rules. See, any live cell has different set of rules and a dead cell has a different set of rules. So we would handle that case there. If neighbors less than 2, that means count of neighbors with value 1 is less than 2. See, this first condition. This live cell would be dead. So we have to replace this value with 0. Or neighbors. There is one more condition we can add in the simple statement. Greater than 3. This condition. Any live cell with more than 3 live neighbors tries. So we concatenated these two statements into a single if statement. Rule 1 and 3. I would just write it down here. See, these comments will help you explain the code better to the interviewer. You would even find the errors easily, and the interviewer would be able to understand your code well. So now board of ij we would substitute by 0 in this case. Now for the next condition, which is if neighbors is equal to true, or if neighbors equals to 3. I'm writing these statements from here because I need to check these conditions. So this is the second condition. Rule 2. Board of ij. See, the second says the neighbors lives on to the next generation. So this live cell would remain live. So I would just mark it as 1. So we did 3 rules. Now the fourth rule depends on the cell being dead, which we are currently at. So we would do that else if condition. Else if board of I and j is equals to 0, which is the rule 4. If neighbors equals to 3, which is the condition here, the dead cell would become live. See, we are doing the changes to the board itself. So we don't need to return anything. We modified the board itself. Now let's run the code. So it passed all the test cases. And it has a time complexity of n square as we are iterating over the whole board. See, we cleared it within time. So let's stop time and restart it. So this was a good problem. You only had to remember these statements and convert these statements to code. It was that simple. The acceptance rate is good enough for this problem. Follow-ups. This can be asked in the interview. Could you solve it in place? Remember that the board needs to be updated simultaneously. You cannot update some cells first and then use their updated values to update other cells. In this question, we represent the board using a 2D array. In principle, the board is in to address these problems. Again, we would focus on a particular area for this one, and this we did using a test. If you have any questions, you can ask. I'm ready to answer any of your questions. Let me check if you have any questions. Okay, wait a second. I need to see the live stream. Okay, what is this playlist? So T33 entitled. Actually, this is an Amazon interview playlist of 45 questions. I will just type it out in the chat also. So it is a recent, past 6 months Amazon interview questions playlist. Okay, so no questions, just trying to grasp your approaches. Good, good. You would understand everything if you just try run and read the question. Let's go to the next question now. Okay, we solved the game of life. I think valid Sudoku would also be a two different problem. Should we solve this? Okay, let's solve. Valid Sudoku. So this is also one of the 45 questions asked in an Amazon interview. Determine if a 9 plus 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3 cross 3 subboxes of the grid must contain the digits 1 to 9 without repetition again. Note: a Sudoku board partially filled could be valid but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. So what it is saying is that whatever the given values are present inside the boxes, they should not get repeated. You don't need to worry about the empty places and whether these empty places, when filled, would give us a proper solvable Sudoku board, is what they are saying. So has 5, 6, 8, 4, 7. So none of them are repeating. This 3 cross 3 sub Sudoku board of elements valid for every 3 cross 3 board. You can check. So what we are doing is checking every row and the elements present inside them. So whenever we find a number instead of a period inside our board, we would put it in our rows there. So we can use set here easily to have a unique and without repetition element. Because while traversing the row, if we find an element which is already present inside the set again, that means the element is present inside that row more than one times, and that we do not want. So we can directly um, return false in that case. Same goes for columns as well as these 3 cross 3 subpseudoctets. So we would need 3 sets. This is so what they would test in an interview is your ability to convert these instructions to the logical code. So I gave you the approach. Now for 3 4 minutes try to code out in your favorite language, be it C++, Java or Python. Then I would discuss the solution and we can have a working solution. Let's take a quick 5 minute break. I will start the timer. Okay, so let's start our session again. Let's code up the solution for this problem. Valid Sudoku. For I in range 9, for j in range 9, we would have element as code of ij if element is not equals to period. Results plus equals to I element j Now we would return if length of result is equals to length of set of result. It is passing over the student. It cleared this problem too. Actually, I have some work to do, so I am ending this stream a bit early today. Hope you have a great evening. Bye bye. Let's meet tomorrow. I would upload today's problem of the day as a separate video, so you can watch it from there. Today's problem is a very good one. It is a hard problem, so please watch it from there. And sorry for ending the live stream a bit early today, but it is what it is, I guess. So have a great evening. Bye bye.